Yo, 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 yo. Hey, everybody. We're going to talk about scientific notation. So what we're doing is we're combining two different sections, combining 2.2 and 2.3, because they're really, 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 really simple. So hopefully you've seen scientific notation before, maybe in science class, possibly. And if not, it's okay. We're going to pretend like you've never seen it before. So what scientific notation is it is a way to represent very, 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 very large numbers and very, 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 very small numbers. And it's just kind of a shortcut because people don't want to write all these zeros when we have them. So what we're going to do is we're going to talk about what scientific notation looks like and what how we convert to and from scientific notation. So actually I want to start on the key terms area because there's no key terms, but what I want us to do is write an example of scientific notation in key terms. Okay, so a number written in scientific notation is always going to look something like this. It's always going to be some type of decimal times the number 10 multiplied to either a positive or a negative power. We'll call this one, we'll make this one to the 8th power. This is a number expressed in scientific notation. Now, a couple of things I want to point out is this number right here has to be, the first number before the decimal has to be between 1 and 9. It has to be really between 1 and 10. Okay, so as soon as I have 10, it's no longer in scientific notation. So it's always going to be 1 point something, 2 point something, 3 point, 4 point, 5 point, 6 point, 7 point, 8 point, 9 point something. Okay? So that's the first thing. The first number has to be a number written, this decimal has to be between 1 and 10. Next, it's always going to be multiplication. Oops. Always going to be multiplication. And then you're always going to have a 10 to some power. Okay, every single time. So it's always going to look like this. The only thing that's different is it might not be 2.3, it might be 3.75. Or it might be 10 to the 9th power, 10 to the negative 4th power. So what this number is this is a different way to represent a larger number. I could actually figure out what 2.3 times 10 to the 8th power is. I could actually do 2.3 times, well, whatever 10 to the 8th power is. Well, that's 1, 2, 3, 4, 5, 6, 7. That's 8 zeros. I just did 10 times itself 8 times to get 100 million. And then I can multiply these two values. And if I wanted to do that, that would tell me what 2.3 times 10 to the 8th power is. So instead of writing it this way, if I actually did that, it would be 230 million. So 2.3 times 10 to the 8th power is the exact same thing as 230 million. Now, sometimes in math we like to be, I don't know if it's lazy, but we like to take shortcuts because we don't like to write a ton of zeros. And so we like to write this, take a shortcut and write it like this, especially when we have larger numbers, especially when this is like to the 27th power. Okay, so scientific notation is just a way to write a really large number like so, or if it's a really small number, and I'll show you an example of that in a little bit. So here's what we're doing. We are going to learn how to go from here to here, how to see a number written in scientific notation and how to change it to standard notation. And then we're also going to look at how to go from standard notation to scientific notation. And the way we do it, you guys, is by counting. Super, super simple. So what I mean by that is this is to the 8th power. Okay, so I'm going to erase some of this so you can rewrite it. So this is to the 8th power. So because this is to the 8th power, that means what I'm going to do is I'm going to move my decimal to the right 8 times. So I move my decimal to the right once, and I have 7 more times to go. So that's 1, 2, 3, 4, 5, 6, 7. And that's why I got 230 million. I just move it over 8 times. But when I run out of times, we just add zeros. Let me show you more examples of this. So let's actually skip over here to 8 and 9. because 8 and 9 is asking me to write my numbers in standard notation from scientific notation. So again, this is an example. We just count the power. So because this is 7.034 times 10 to the 9th power. This is a number written in scientific notation. This is between 1 and 10. Okay. I have a decimal, 3 numbers, doesn't matter how many digits we have afterwards, and it's times 10 to some power. Well, because it's 10 to the 9th, I have to move my decimal to the right 9 times. So I'm going to move it over 1, 2, 3 times. That gets it to 7,034. So I moved it 1, 2, 3 times. I have 6 more times to go, so that means I have 6 zeros. So it's 7034 plus the 1, 2, 3, 4, 5, 6 zeros. And that's done. That's 7,034,000,000. So this is just another way of writing this. Now to go the other way, let's say I wanted to write a number in scientific notation. Well, what I do is, again, I count, but I have to move my decimal until I have a number between 1 and 10. So if I move it over once, twice, 3 times, that's going to give me 6.4. 6.4 is between 1 and 10. So, and I moved it over once, twice, 3 times, so that means my power is 10 to the 3rd power. And that's it. There's really nothing else. So, for this one, try it on your own. See if you can write this number in scientific notation. Just try it, see how you do. See if you can count how many spots and in the right spot. All right, so I know it's going to be 5.7. And the reason why is because if I put my decimal here, that's going to give me a number between 1 and 10. 5.7 is not less than 1. And it's not more than 10. And then to get there, I had to move it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I had to move it over 11 times. So that's 10 to the 11th power. And I'm done. Pause and try this one. See if you can go from standard to scientific notation. All right, so I move it, just my decimal over 5 times. 1, 2, and then 3 more, and 3 more times is 3 zeros. So it's 2, 3, 6, 0, 0, 0. So that's 236,000. Okay, so now this is talking about the light year. A light year is a distance that light travels in a year, and is equivalent to this many kilometers, right? This distance in scientific notation. We use in space and astronomy and in science, we use these numbers all the time because everything in space is very, very far away from each other. So if you haven't done so, pause and try 5 and 10, please. Okay, so for number 5, you should have got 9.461 times 10 to the 12th. So my decimal, I always have one number in front of it. It's between 1 and 10. That's where I knew to stop, and I had to move it 12 times to get there. This one right here, so just because there's no decimal there, no decimal means it's the same thing as having like 0.0. So that was me adding a 0.0 there. So I'm still moving it over 6 times to the right. So I moved it over 1, 2, 3, 4, 5, 6 times to the right, which is 5 million. Now, we said it's ways to write really large numbers. It's also a way to write really, really small numbers. So these are numbers that are tiny, tiny numbers. We use these when we're talking about an ant, or we're talking about cells, or the atom, or electrons, or neutrons, or anything like that in science. So really, 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 really small piece. The nucleus of an atom. So a lot of the smaller, tiny, tiny, tiny pieces that we can't even see. They're so small that they have a ton of zeros in front of that decimal. So we use scientific notation for that. The only difference is now we have a negative exponent. And instead of moving to the left, now we just move in a different direction. So here I have a really small number. So my rules are still the same. I still have to have my number written between 1 and 10. So this one, my decimal is on the left. So now I'm going to move it to the right. 1, 2, 3, 4, 5. I'm going to stop here. So I still have to have a number between 1 and 10. So that's 8.29. And I moved it over 1, 2, 3, 4, 5 times. So that's now going to be 10, not to the 5th power because it's a really small number, the negative 5th power. Same thing when we're going the opposite way. If I have a negative exponent, now instead of counting 6 times to the right, I'm just going to count 6 times to the left. So this decimal, because it's to the negative 6, I'm going to move it to the left once, and that means I got 5 more times to go. So that means I have 5 zeros. So that's a decimal. 1, 2, 3, 4, 5. 1, 0, 4, 5. And I'm done. Okay, so I moved it over 1, 2, 3, 4, 5, 6 times. Go ahead and try 5 and 10 on your own right now. Try 5 and 10 on your own with the negatives right now. See how you do. Pause it. Okay, so those are your answers for 5 and 10. So this one, I moved my decimal over 7 times to land between 3, land right after the 3. So I got 3.02 times 10 to the negative 7th, and I move it over 7 times. And it's negative because it's a very small number. This one, I'd move it over to the left 5 times, which is why I have 4 zeros after the decimal, and then 99. And that's it. Try 6 and 11 if you haven't done so already. So pause, try 6 and 11. All right, so there's your answer for 6 and 11. Number 6 is 7 times 10 to the 6th power. I'm sorry, to the negative 6th power, because it's a small number, so it has to be a negative exponent. And I had to move my decimal over 6 times to the right to get there, so that's why I got to the 6th power. And then this one, I know this one's a silly one to write in scientific notation. There's really no point in doing it. But I still got to move it over twice, so that's just 0.01, and I'm done. That's it, guys. Okay, so nothing else to it. Things to remember: negative exponents represent super small numbers. And remember, if we have a decimal like this, that's a very small number. That's way, way, way less than even 1. Tiny, tiny number. Okay, that's all I got for you guys. Hopefully this helped. Hopefully this is pretty simple. Do the independent practice. Thanks for watching. Greediest out.